get started. So we're getting towards the end of it. We only have 2 more weeks of learning objective content. So we're going to be done with learning objectives by the time we hit the next break. And then the last week of content is going to be application objective only. And then a week of review, which for review, I don't think I mentioned this yet this semester, but for review, if I do review, like, nobody seems to ever care, to be honest. So what I do for review is I create a Piazza post and put it up for a vote and let you all tell me what you want to see. So whether it's review or not, it's whatever. And then I'm only reviewing the things that you specifically asked me to review. I'm not just reviewing the whole course. I don't know why, but nobody really is interested in those lectures where I used to just rip through the whole course in a lecture or two and just do a speed run through the whole, all the content. Nobody ever cared. I don't know. But so I do it different this time around. So we got 2 more weeks of content. Polymorphism this week. This is teaching us how to do task 7. So let's take a look at that quick. These last 2 tasks, 7 and 8, are some of my favorite types of assignments. I don't know if anyone else agrees, but it's a very simple problem statement, and then it's trickier to actually figure out how to solve the problem. And if it ever loads, man, the Wi-Fi kills me. The problem statement, first we're going to get movie ratings finally. So we're going to have a file full of ratings for movies with the songs, the song information, and the ratings all come in one file. But for movies, we only have movie information in that first file that we read in task 6. So now we're going to get ratings added to those movies through another form of data. And it's very similar to reading the song ratings file, except since you're reading data from 2 different files, it gets a little different. But you already have the first one written. So populating movie ratings. And then what the task is really all about is writing this media library file, which is going to be populated with both movies and songs. So we need one class that's going to work with ratables and be able to mix movies and songs. And we want this top K ratables. This is the main primary method of the assignment. Top K ratables is going to give you kind of what the name implies, the top K ratables out of the media library. So you add a bunch of songs, you add a bunch of movies, all with ratings, and you want the best songs based on their Bayesian average rating. This is what a lot of what we've been doing in the past tasks has been building up to. What are the top songs? So if you say top K ratables of 10, K is 10, give me a top 10 list. And this is what I use for taking all the song data. I'll populate this with just songs from all of the data that you put into the song rating app, and then get like the top 10, top 20. I did the top 1,000 songs just so I get all of them. I think there's, I don't remember, but like 150 songs, I think, I want to say were added, maybe more. And then just get the top, all of them, just by increasing K to a large amount. So this is what we want to build. A media library that can have songs or movies populated with all the media, and then get the top K lists based on their Bayesian average rating. And for this one, I don't specify how you sort, how you're going to handle the top K, how you're going to do any of that. It's up to you. You have lots of tools in your toolbox at this point to be able to do that. You can write comparators and use the comparators directly. You can write your own sorting algorithm if you're so inclined. You can use Java's built-in sorting algorithms. You can use a BST. However you want to get the job done, give me the top K ratables, mixing songs and movies. So let's learn. So the big thing of how to do that is the mixing part. How do we have one class that's going to work with both songs and movies? And the answer is polymorphism. So let's finally talk about this. This has been a topic that that kind of comes up throughout the semester, and I keep saying, oh, we'll learn about that in polymorphism week. And I keep putting it off. Well, now's the time. Let's talk about it. Polymorphism. And I don't have it's a really powerful topic, but the definition of it actually doesn't take too long to tell you what polymorphism actually is fundamentally. The implications of polymorphism, the applications of polymorphism are many. In fact, all of application objective week, that week after break, is the state pattern, which is an application of polymorphism. We can't do that without both inheritance and polymorphism. But let's see what it is. So it's been a while since we've seen inheritance. And the quiz on inheritance and polymorphism really is, polymorphism and inheritance kind of go hand in hand. So the quiz is a lot of what we talked about in Inheritance Week, so let's review that and then talk about what polymorphism is. And to do polymorphism, to use polymorphism, we need inheritance. They go hand in hand. They're kind of one and the same, but not really. But you need inheritance to do polymorphism. So we had inheritance. Last time we had this game item class that was extended by weapon and health potion. And we saw that weapon and health potion inherited all of the behavior from the game item class using the extends keyword. So we extended the class, which inherited all of the, I'm on app usage. Oh my goodness. Why is everything not the way I want it to be? All right. So we use the extends keyword. Weapon extends game item is how we use inheritance in our code. So we extend the class or inherit from game item, and that gives us all of the state and behavior from the game item class. That's the two instance variables, the constructor and this use method. We get all of that functionality in the weapon class by saying, let's inherit from game item. Same with health potion. We grab all of that information. And the big thing I said 100 times, but I still haven't assessed you on, it's not until the quiz next week, is whenever you call the constructor of a class, the superclass constructor is always called. So when we say new weapon, you have to make sure you put in that game item constructor on the stack. That's an easy instant fail on the quiz next week. Make sure you have your superclass constructors, because that's one of the only things, like without that, that's one of the only, what am I saying here? That's one of the only things that we're adding using with inheritance and polymorphism is that superclass constructor. If you miss the superclass constructor, most of the rest of the quiz is the classes quiz, which was already behind us, quiz 1. So on top of quiz 1 content, it's the superclass constructor, and it's which method is called when we call a method, and there are multiple methods with that same name in all of the classes available. How do we know which object or what class to go to find the definition for that method? Those are really the only two things that I can assess you on that's specifically inheritance and polymorphism. So if you miss one of those two things, yeah, that's an easy fail. So make sure you're not forgetting those superclass constructors. Very, very important on the quiz. And we use this extends keyword, and this extension could be implicit or explicit. The weapon class explicitly extends game item, because I typed extends game item in my code. So it's going to obviously extend game item because it's right there in the code. Game item also has inheritance, is also inheriting from another class, but it's not so obvious. This is an implicit extension. If an object, if a class does not explicitly extend any other class, it implicitly extends the object class. So game item extends object, weapon extends game item, or weapon inherits from game item, and game item inherits from object. So we have this three classes that interact with each other, and the weapon class at the bottom of this interaction has all of the state and behavior of the weapon class, of the game item class, and of the object class. It gets all of that functionality in this one weapon class. And we call this is a relationship. I don't know by now. I don't dwell too much on the vocab itself, but this one I do find a little helpful. This is a relationship. So whenever you extend a class or whenever you inherit from another class, that class or objects of that type are I gotta keep it in the singular. Really is that type. So if I have an object of type weapon, that object is a weapon. That one should be pretty straightforward. But that object, in a very real sense, is a game item. That object is an object. This is a relationship. This happens every time we have inheritance, and this can be direct or indirect. So a weapon is directly a game item because weapon extends game item, but it's also an object because it extends something that extends object. So this can be indirect, and there could be 100 links here. Weapon could extend something that extends something that extends something that extends something all the way up to object, and that still is objects of that last type is an object of type object. gets weird having it called object, is an object of type game item. No matter how many steps there are in between, it is any of its supertypes. Any and all of its supertypes is a relationship. So weapon is a game item, weapon is an object. Bless you. And since everything extends object eventually, either directly or indirectly, every single thing in object, every single object in Java is of type object. Polymorphism, so that's review of inheritance. Polymorphism, in two senses, if an object is a certain type, it can be stored in variables of that type. And that's really it. That is what polymorphism is. Done. That's polymorphism. So if an object is a type, it can be stored in variables of that type. And once we have a variable of a type that doesn't match the type of the object we have, and we take this object and store it in that variable of a different type, we're using polymorphism. And I'll try to keep making the distinction clear of what polymorphism actually is. This is polymorphism. I think the slide shouts it out pretty loudly. But where it gets confusing is, where's the line between inheritance and polymorphism? And that's what we'll hit you with on the interview. We want to make sure you understand, okay, that's inheritance, that's polymorphism over here. If you're not doing this, if you're not taking advantage of this, it's not polymorphism. It's going to be in the realm of inheritance. It's only when you're doing this that it's polymorphism. So what does this actually mean? Obviously, I'm not just going to leave it at this and say you know polymorphism now. Let's see what this actually means. So polymorphism, if we break this down, poly, many, morphism, forms, polymorphism, many forms. That one type can have many different types based on its inheritance structure is where we get to start using polymorphism. So the fact that weapon is 3 different types, it has many forms, we can treat a weapon object, or rather a reference to. I'm not going to say reference to every time just because I don't want to use that many words. But a weapon object is a weapon, is a game item, is an object, and we can treat it like any of those 3 types. So this code is allowed. We've seen this once before in BSTs, and I said, don't worry about it. It's polymorphism, but don't worry about it. But now I want to shine a light on this, that this is allowed. A weapon is a weapon. This first line, we've seen this thousands of times. We've seen this all throughout the semester. No surprises there. I have a weapon object. I'm going to store it in a variable of type weapon. Yeah, okay, makes sense. The second one is where we start using polymorphism. I have a weapon object, and I'm going to store it in a variable of type game item. This assignment is allowed because a weapon is a game item. In a very real sense, it is a game item. We can store it in this variable. This assignment is legal. No compiler errors. The code happily executes, compiles, runs. Everything's fine with this. Everything's perfectly fine with it. Storing a weapon object in a variable of type object, still fine because it's in its inheritance structure. It is a superclass, not directly, but it is a superclass of the weapon class. So that assignment is allowed. All 3 of these assignments are allowed. Dot. I assume that was an edited message. There's another keyword, implements, that has similar usage as extends. What's their difference? Implements is for inherited. Oh, I almost said implements is implements. Implements is when you want to inherit from an interface. Then you use the keyword implements. Extends is when you want to implement. I messed it up again. Inherit versus implement. My brain's got to separate them. Extends is when you want to inherit from a class, from another class. But if you're inheriting from an interface, you can use implements. And the reason there's 2 different keywords for this is you can implement as many interfaces as you want, but you can only extend one class. Or else why don't we just use extends for everything? That's going to be the difference. In interface, I do have some slides on this by the end of lecture. But just very briefly, interface is kind of like a class, but it only has abstract methods, and abstract methods are methods that don't have definitions. Yep. Oh, I wasn't ready for that one. Like I'm not using it tongue in cheek or something. Like I'm not saying a weapon is a game item and being like, well, it kind of is like a game item or something. Like we can store a weapon in a game item class because a weapon it really is a game item. And the kind of analogy for this is rectangles and squares. Like a square is a rectangle. It meets all the criteria of a rectangle. If you need a rectangle, if I say, hey, give me a rectangle and you give me a square, I'm happy with that because that is a rectangle. I got to think of an example where it's not in a very real sense. Like, and I might fall short on this one, but when is it not in a very real sense? Biology. Yeah. Hey, but that is real. Like a dog is a canine would be the analogy there, but it is really a canine. There might be one there, but I'm coming up short. It's I'm blanking on it. Yeah.
Could you say like with the real world parent and child relationships is not like I'm not in a real sense my parents or like
That could work.
I inherit someone.
Yes. Yeah. I like that one. Where if you do something that's something that your father would do, people would be like, "Man, you're so your dad." They don't mean in a very real sense. They don't mean literally like you are your dad. They just mean that you're exuding some of the same behaviors. Yeah, that one works. I like it. Thank you. Where you just have some of the behaviors. Where if I do some live coding and you say, "Oh man, he's so Paul right now. Jesse's Paul right now." I'm not literally Paul. I'm just doing some things that Paul would do. Yeah.
So all three of those variables, like they are all functionally like they all have like the weapon properties, right? They're all weapons. So like why would we want to like do like weapon or object?
Yeah. Why would we want to do this? That's the $1 million question here. Why? Because we can do this, but why would we ever? And I got a lot of slides on this, so I'll get into it. If I don't answer your question, make sure you remind me and ask again. Okay, so that's polymorphism. This is the fact that we can store objects in variables that don't match their type as long as it matches one of their supertypes. Polymorphism. Okay, why do we do this? This is polymorphism, but why, well, not even why would we do this, but what are the implications of this? Like how does this change my code? If I just have one variable here and I decide to make it weapon, or then I change my code and decide to make it game item or object, how is that going to change the behavior of my code? And I'm going to start with a big downside. So there's a huge downside to polymorphism, and I think polymorphism is so strong, it's going to sell itself so much that I'm going to start with the downside and tell you the bad stuff, and then we'll get into why we would actually use polymorphism. But the downside is that we can only access state and behavior associated with or rather known to the type of the variable. So if we store a weapon in a variable of type weapon, we can access all of the state and behavior, or at least all the public state and behavior from the weapon class. Every method that's known to a weapon, we can access. Everything's fair game. Everything's on the table. Once we store it in one of its supertypes, once we put a weapon in type game item, we can only access state and behavior known to the game item class. It's still a weapon. The object stored in that variable is still a weapon. It still has all the state and behavior of a weapon, but when we store it in a variable of a supertype, we can only access state and behavior known to that supertype. So a game item doesn't know about the getDamage method. GetDamage was a method that we wrote in the weapon class itself. Nowhere in the game item class or any class that it extends does it know anything about a getDamage method. So when I store this weapon in a variable of type game item, I cannot call getDamage. Not allowed. If I uncomment that line, it's going to be a compiler error. Program doesn't run, everything breaks, doesn't work. Same with object. The object class definitely doesn't know about a getDamage method, so I can't call it through a variable of that type. So I'm limiting my functionality here. Yeah.
So when we store the weapon in a game item, kind of like we cut off the state of behavior from the weapon, but
Yeah, it's a little more nuanced than that. So the weapon still has all the stain behavior of a weapon class, but I can only access the stain behavior known to the game item class. But we still get some benefit from the weapon class. So if the weapon class overrides one of the game item methods, we do still get the overridden method. So we still get weapon-specific behavior, but we can't access it if the superclass, the variable type, the variable class doesn't know of the existence of that method.
Can you say afterward, like, weapon 2 or weapon 4 equals weapon 2?
What type for weapon 4? Depends on the type of weapon 4.
Weapon 4 is a weapon.
Oh, weapon. Oh, you did say. Yeah, sorry. I missed it. Weapon 4. No, we can't. So you can't say weapon 4 equals weapon 2 because weapon 2 is known to be a game item, but it's not known to be a weapon. The variable doesn't know that it's storing a weapon, so it won't be able to make that assignment. Good question. Cool. Okay. But we can go up in the super types. So the use method was defined in the weapon class. The game item class. It was defined in the game item class, so we can access that from both weapon 1 and weapon 2. Weapon knows about the use method because it inherited it from game item. Game item knows about the use method because it defined it. It's the one that defined this method. But object does not know about the use method, so we can't call it from weapon 3. Yeah, no problem.
So then would it still use weapon to overridden use method?
Yes. Yeah, so both of these, no matter what, whether weapon overrides use or not, whatever happened with this use method, both of these method calls will call the same method with the same definition, the same functionality, no matter what. So if weapon overrides the use method from what called from game item or weapon, we're going to get the overridden method every single time. Yeah.
Will it get the overridden method if you don't annotate the override?
Yep. Yeah, the annotation, having it there or not, has all of the same exact behavior in our code in every single way. The annotation just helps us give the compiler a heads up. It's only for our benefit.
Yeah. I think I missed something you said before. So your weapon 2 that's a type of game item, and weapon 3 that's type of object. But they still, let's say they stored an object that had the same. Well, no. Let's say they store the same object. So would those two objects equal to each other, even though the variable types are different?
Ooh, I gotta think about that one. I don't know. So if I did weapon 1 equals new weapon, weapon 2 equals weapon 1, weapon 3 equals weapon 1, and I said weapon 3 equal weapon 2, or rather dot equals. Equal I think would be true, right? But dot equals, weapon 3 dot equals weapon 2. I want to say yes, but I'm not 100%. If it would still just be comparison by reference, or if it would say the types of the variables are different. I want to say I would expect it to return true. I would expect it to say these objects are equal because they refer to the same object. And the object is still of type weapon, regardless of the variable where it's being stored. So I would expect it to return true, but I'm not 100%. Yeah.
So let's say that the game object class did have a damage method, but it was overridden in the weapon class. If weapon 2 called its damage method, it would use the method in the weapon class.
Yes. Yeah. If weapon overrides that, yep, it'll get the overridden method.
Is that the reason why you implement interfaces so that you can use behavior inside of classes, even though it wasn't explicitly defined?
Yes. 100%. You nailed it. That takes a while to really understand, so you're definitely ahead of the curve on that one. Why would we? I haven't defined abstract methods yet, but abstract methods are methods that don't have a definition. They exist only to be overridden, and then the question is, why the hell would you even do that? It's so the method exists in the superclasses, and we can, when we're using polymorphism, we can rely on that method existing. Even though we don't know what it's going to do, it will exist. And our code will compile then. That's why we use abstract methods. But if you don't want to think about that yet, don't worry. We'll get to it by the end of lecture. Yep. Oops.
That will be the method as well. Like any code that you call will be called from the class.
Yes. Yes. And we're getting a little ahead of the slides. This slide is where I answer a lot of these questions. But now it's already out there. So when we're using polymorphism like this, the type of the variable, and this gets a little nuanced. So remembering this, I don't know, it's just something we gotta get used to. The type of the variable determines which methods can be called. If the variable doesn't know of the existence of a method, it can't call that method. The type of the object determines which method is actually called. So when I call this weapon 2, weapon 1, weapon 3, these variable types are going to define, okay, this is a legal method call, this is a legal method call, this is not a legal method call. The variables are deciding that. Variables decide, can this code even compile? Is this allowed? Once the code is allowed, the variable says, yep, we're doing this. Then the variable's job is done. Then it's just the method being called. Just like we've done all semester, it's going to be by the type of the object. So it's going to go head over to the heap. Once we hit the dot operator, we're over on the heap. It doesn't matter how we got there. What variable we use to get there. These variables are storing references. We head over to the heap. We're at an object of type weapon. And the type of the object is going to determine which method is actually called. So if weapon overrides a method that was defined in the game item class, once we hit the dot operator, we're at an object of type weapon. We're at an object of type weapon and we're calling the use method. We're heading over to the weapon class for the definition of that method. If we don't find it, we'll head over to the game item class the same way we did with inheritance. But all of that structure, all of that searching for the method that's going to be called is the same thing we've done in inheritance because we've already headed over to the object. We're done with the reference, we're done with the variable. We head over to the object and everything's the same as it's been in inheritance week. The variable is only, the type of the variable is only deciding if the code's going to compile or not. Which if you want to cheat a little bit on the quizzes, the quizzes are going to compile. We're not giving you broken code. Like if we give you broken code, that's a complete accident on our end, on me and the TA's end. That's a question we have to, a question that we put out that's broken. We have to handle that in grading. Probably, I don't know, give you a new quiz or just be very soft on the grading. Something we'd have to do something to mitigate that. The quizzes are going to compile. You don't have to worry about that. Which, if you don't think about the polymorphism at all, and you don't think about the variable types in the quiz only. Of course, you have to, for your career, for the programming tasks, all that, you have to understand this. It might be an interview question as well. You'll have to understand. But for the quiz, you know it's going to compile, so you can kind of ignore the variable types. Don't tell anyone I told you that, but you can kind of ignore the variable types and treat it as a strictly inheritance quiz. Everything you know from inheritance, follow that same structure. Once you get over to the object, it's on to the object to determine which method is actually called. That's something I've had in the past. Students would look at the quiz and think that it wouldn't compile, think we did something that we're not allowed to do, and their answer, instead of a nice, beautiful memory diagram, would be, this code don't compile, QED, and then submit that. That's not going to ever be the answer. That's not going to be the actual answer. I haven't seen that in a while, but just so you know, the code will compile. We're not going to really be able to test that part of polymorphism on the quiz. Interview and task, yes. All right, moving on. And then if we're calling toString, toString is defined in the object class. So any object we have, we're going to be able to call toString on it. Every single object in Java has a toString method. This is why even when we're using generics, we can call toString and dot equals. We can call these methods on our objects because every single object has to have them because they all have to extend object either directly or indirectly. So we can count on every single object having a toString. Every single object, so not every single variable because you have to exclude the primitives. It's always one caveat there. You can't do int x equals 7, x dot toString. It's not going to work because it's not an object. Okay. Any more questions on that? All right, so finally the big question. Why would we even do this? I said polymorphism is the greatest thing ever. Been waiting weeks to tell you about polymorphism. It's freaking awesome. And then I start with, here's a downside. It limits what you can do. There's some methods you can't even call. Yeah, it's a weapon, but you can't call get damage on it because you stored it in a variable of a different type. Why would you do that? Why would you ever do that? The answer is to simplify other classes. Because this alone, what we had on the previous slide, you would never actually do this. There's no reason to say game item weapon equals weapon. There's no reason to do that because all you're doing is limiting your functionality. Don't ever do this. Just store it in a variable of type weapon. If you're in one single stack frame, there's no reason to ever make this assignment. These are legal assignments, but why would you ever do it? Just store it in a variable of type weapon if it's a weapon. But when that assignment is across stack frames for a method call, this is where we see the power of polymorphism. In the player class, if we write a use item method, if we want to write use methods, which we had in inheritance week, we would have a use health. Actually, I don't know if I remember if we did or not. But we would have a use health potion method and a use weapon method. We'd have two separate methods depending on which type of game item we're trying to use. And then if we want to add a third, fourth, or 100th game item, we would have to have 100 different methods for all the different types of game items that we can call because the type of the parameter has to match the type of the argument. So we have to have a separate method for every single type. But not with polymorphism. With polymorphism, we're going to write one method here. We write this use item method that takes a game item. And that method can be used with every single game item type in our game. Whether we have hundreds, thousands, millions, however many, I don't know who's going to type a million classes for a million different game items, but doesn't matter how many types of game items, how many classes extend game item. If other classes extend those classes and you have this huge inheritance structure, this whole inheritance tree rooted at the game item class, doesn't matter. This one method takes care of all of it because the use method is known to the game item class, so it can be called. This code's going to compile no matter what type of game item you give me, whether it's a health potion, weapon, or anything else. As long as it extends game item directly or indirectly, that method is going to use that item. One method for any game item type we want. This is where the power really comes in. And we still have the assignment. If we have a weapon that we want this player to use, this player is going to do use item, game item of, or use item of that weapon, and it's going to be game item, item equals weapon is going to be the implicit assignment there, assigning the parameters to the values of the arguments. But that assignment is across stack frames, and that's where it actually gets useful. So we would never do this, but when this assignment is across a stack frame, this is the parameter and this is the argument, that's when it gets useful. Now, this player class is, unless we want to change behavior specifically to players, this player class is kind of done. Well, it's not. We're actually going to add to it in the next lecture, but this use item method is done. And player can use any item in our game, even items that don't even exist yet, that we haven't even dreamt up yet. That method's going to handle it. Yeah.
Is it intentional that the use method doesn't have public divided?
No. I wish I had public there. I didn't even notice that. But since it overrides a method that's public, it'll be public. Yeah, I just missed the public there. I wish I had public. Oh, I got ahead of my slide here, but I already said it like 5 times. I don't want to say it again, but the slide will say for me this time. No questions in chat. Any other questions? Yep.
So basically what it does is like, just like, let's say we put a weapon in the document, it just becomes a game item in that stack frame. And then what happens when it's done with the stack frame? Let's say it returns like the, let's say it returns a different thing. So what's not with the variable.
So the type of the object does not change. I think that's getting to your question. So the type of if I give this a weapon, this is still, the value that's stored in this variable is still a reference to that same object, and that object is still of type weapon, but I'm accessing it through a variable of type game item. So the variable and the object type are mismatching. So this can still follow that reference as long as it's accessing something known to the game item class, like the use method here. But I couldn't do item.getDamage here because this method has no idea that it's even going to be called with weapons or health potions.
But let's say you return like, kind of like the center, I guess. So you return like this item equals, like, let's say like a weapon. So how would that work? Would it set it to like a type of game item, or would it just keep it as type weapon? If we're trying to set it. If this dot item equals item, it'll still be that same reference. That'll be an assignment by reference. So it'll still store a reference to the weapon object. That's what you're asking, right? Yep. Yeah, because it'll still be the same reference to the same object. But the player won't really be able to tell that that's a weapon. Players can't tell. Like nothing, the weapon and health potion won't show up in this player class at all. That's the way we want it. We want to add different items that the user can interact with in our game. We don't want to hard code all of that into the player. Like these are all of the item types that you can encounter in the world. We're going to write something like this, and the player shouldn't care what the type is. In a real game, there will be methods like, give me the image for this item. Like you go to your inventory, you have a whole bunch of game items in there. You'll see the images. You'll see they'll have like a get stats and get description methods. You'll be able to see what it was. Like you as a player will be able to know. But the player class itself, the code doesn't care what type it is. And then when you call a method like use on it, it'll depend what that item type actually is, and it'll get the overridden behavior from that class. Yeah, we can't access like get damage, but it's worth it. If we can write that one method that handles all kinds of things, if we can write our BST to take a comparator of songs, and then we can use a title comparator or a Bayesian average comparator or any other comparator we're ever going to dream up in that one method call, that's worth it. Yeah.
So that use method, say like it was in like the weapon, and the weapon use it like called like all its private behavior to like whatever it was for that weapon. That's like still something we could do. Like it would just call whatever that weapon does.
As long as we're calling a method that exists in game item and is overridden by method, then we can access it. And generally, if that's ever a problem in our code, if we're like, man, there's this method I really want to call, it's only in the weapon class, usually what we're going to do is reorganize our code, get that method up in the game item class, and then tell every game item, hey, I want to use this method in the player class, so you're all going to have to implement it. Then depending on what the method is, we'll give it some default behavior so we don't have to define it in every single extending class. Yep. Mm-hmm.
So with this code, players can use players? Is that how it is right now?
Yes. Players could use players. The code in the repo, if a player uses another player, we would count that as an attack. So players would attack other. If you're playing a game and you see a player and you click the interact button, swing the sword or whatever their attack, whatever their equipped weapon is. That was the intent. That was the design of this. And we can take this a step further. We can have data structures that mix types finally. Some we took for granted in JavaScript and Python. We could just stuff anything in a data structure and Python, JavaScript, they'd be happy to just have all kinds of different types in an array. That'd be fine. We can't quite do that in Java. We have to have array lists, for example, that have a specific type, a generic type. We specify what that type is, and then that array list can only ever store objects of that type or values of that type. Objects of that type. You can't have primitives. But once that type is a super type that's extended by multiple different other types, concrete types, now we can start mixing things. If I have an array list of weapon, if I have an array list of health potion, I can only store those types. But if I have an array list of game item, now I can have an inventory of any type of game item ever. Now this player can store any game items in their inventory, and I can have methods that work with the game item class and start accessing, start interacting with these game items in a more versatile way than hard coding health potion, hard coding weapons. I forgot what my other thing was. Yeah.
So if I have an array list of game items, even if I make all of them weapons, would I only be able to call methods of the game item class and
Yeah.
not of the weapon class?
Yep. Yeah, because the player class doesn't know anything about the weapon class at all. Like, I wouldn't even have to import the weapon class here. So it doesn't know anything about it. It only knows about the game item class. So even if I only pick up weapons in my inventory, I can still only use game item methods. Of course, this is what you're expected to do on the homework. If you have an array list or some data structure, I'll say data structure. I don't see it too often, but the intent was that you would use a BST. A lot of students don't do that, but I give you the BST code. Why wouldn't you? But that you'd use some data structure of type rateable, and then stuff your songs and movies in the same data structure, and then sort on that data structure, and then return the top K things. That's what you're expected to do on the homework. You don't want to have an array list of movies, an array list of songs, and then start working with them independently, and then like merging them when top K is called, like get all the results and then compare the Bayesian averages manually. You don't want to get into anything like that. One data structure of type rateable and just mix songs and movies. All the Bayesian average stuff is in the rateable class. So you can have access to all of your Bayesian rating, your Bayesian rating method. You only need one of them. You don't need like average rating. You just need Bayesian average rating. But you have access to that method because it's in the rateable class. You have access to get title. So in your testing, you can check the titles. That's why in the homework, if you read it, it's the titles you can assume are unique, and they should be unique in your testing. Because we only have a get title method. Maybe I should fix that some semester. Put the get ID method in there, but then I have to get IDs for the movie anyway. But you can assume the titles are unique. You have get title, you have get Bayesian average. You can do everything you need through variables of type rateable for task 7. And yeah, we can start mixing types in our data structures as long as all the types have a common supertype, and that supertype is the type for the data structure. So variables of supertypes and data structures of supertypes, these are 2 big applications of polymorphism. And as promised, let's get to abstract. So that is polymorphism. Wednesday, we're doing a memory diagram to really emphasize what it is. Today's all the theory. Wednesday is going to be the memory diagram, and then Friday will be examples in the code. I'll do live coding on Friday. So that is polymorphism. That's all the theory that I have about the topic, about the concept. So let's talk about abstract. So abstract is a keyword that we can use on our methods that lets us not define methods. So an abstract method, if I use the keyword abstract, is going to be a method where I define the signature, which is the name, the return type, and the parameters, including parameter types, but I don't give it a body. This is an abstract method, and I just cap it off with a semicolon, no body. This is an abstract method, which means it cannot be called, because what would you expect to happen if you have a method with no definition, no body? What would you expect to happen when it's called? The common answer would be nothing, which would actually work fine in this case. But what if the method had a return type? What would you expect it to return? If it had a return type of, say, player, what would you expect it to return? I don't know, maybe the default behavior of the default value of null, maybe, I don't know. But Java says, nah, you just can't call abstract methods. We're not going to let you do that. If a class has any abstract methods at all, the class itself has to be abstract. And abstract classes, they're very similar to regular classes with one huge difference. They cannot be instantiated, which means you can't create new objects of that type. You can't call its constructor. I can't say new game item if game item is abstract. Cannot create objects of abstract types because if you could create an object of type an abstract type, then you could theoretically call this method, and then what happens? Java says, nope, we're not going to let you do that. Just can't create objects of these types because it has an abstract method, and I don't want you ever even trying to think about attempting to call that abstract method. So Java's kind of protecting us from ourselves here, which it does a lot. But they can be inherited. So I can extend this class. I can extend game item. I can extend any abstract class, and my job, my task there, or my responsibility, if I extend an abstract class, is to implement all of its abstract methods. So this abstract method exists only to be overridden. We're going to extend this class, override the abstract methods, and then we can be a true class instead of an abstract class. If we don't implement every abstract method, that's fine. We can do that, but then the subclass also has to be, or the child class. It's the one time I say subclass, isn't it? The child class also has to be abstract in that case because it has an abstract method. So why would we do this at all? Which came up in a question earlier. Why would we ever use